My name is D.I. von Briesen, and you're sitting here or standing here in the EcoBox, which is a project of Central Piedmont Community College, and it was originally conceived as part of a faculty fellowship, which is where a faculty member at Central Piedmont Community College actually puts forth a proposal and then is given time off for a semester or spread that semester across 2 semesters to work on the project. So this is the culmination of that project, which started several years ago, and through the generous support of the engineering department, the IT department, and the administrators here at Central Piedmont Community College made this possible. And we hope within another semester or so to have a fully functional lab that demonstrates photovoltaics, rainwater capture systems, insulation, thermal energy, water filtration, and all those other things. So there you go. All right, so here we have, you see the roof of the container. And on the top we have some salvaged sheet metal to use to keep the sun off the box. And we have 4 thin film solar panels. Right now they're temporarily mounted, but in the future we'll probably have 8 or 10. And these are generating on a good day about 350 watts, so 0.35 kilowatts. And those go down into a battery bank, which I'll show you inside. Also, you see the rain gutter there, and all water that falls on the surface of that roof, which is about 500 square foot, is actually captured down in tanks below. This is the second solar install related to the EcoBox on campus. The first was a 1.2, 1.3 kilowatt array up by Pratt, and hopefully we'll get some better panels and get a little more juice going and improve on this system. Okay, here we have a couple of water tanks. These are about 1,000 liters, 250 gallons. And the plan is to have quite a few of these and network them so the water flows in and they all even out, and we also will have a filtration system. Right now the water comes down from the gutter on the roof. It's about 500 square foot. So every time it rains an inch, we get about 350 gallons. It goes into this black tank, and that in turn follows over here. So this water comes out, and visually it's pretty clean. It is rainwater. Basically it smells a little bit like what you get in a lake. There's probably some small amounts of organic material that we're going to be filtering out. But we estimate that in a year we should be able to collect about 12,000 gallons of water. So the key is how much will we use and how much storage do we need and how do we want to filter it. So this is just the very preliminary stages of that. So this is an entranceway. We're actually up on a trailer. The intent of this project is it would be down on the ground, but for permit reasons it was easier just to put it on the trailer. We've actually bought some of the interior furnishings, including the kitchen sink, right? So we have a lot of furniture to put in once we get the interior walls done. Also we have a French door here and on the other side, and another door on the front. So the idea is to create lots of light and airy space. So this is the EcoBox. What we have here is a standard 40-foot high cube shipping container. It's about 9.5 foot internally. So here we have the EcoBox, and it's a 9.5 foot interior. It's a 40-foot high cube shipping container. We're in the process of finishing up the sheetrock. We just have a few more pieces here. We've added insulation. This is blown cellulose. It's actually chopped up newspaper, and if you look really carefully you can actually see the letters from the newspaper. It's recycled, so very, very environmentally sound, and also treated to prevent flammability. You can see that we've been as high as 90 degrees today and as low as 70 degrees. We also have an air conditioner we're experimenting with, but it draws a lot more power than our solar panels generate, so we kind of run it intermittently. We've got functional wiring. We still have to put the covers on and that sort of thing. And watch your step coming through here. And this is really one of the hallmarks of the whole project. Here we have a wind turbine, but Charlotte's not really a very windy city, so it's good for demonstration purposes, but we just wouldn't get enough wind to really generate any power. But this is the solar photovoltaic system, and if you come around here you can look at our charger. And basically it works like this. The power comes in from the panels on the roof. They're combined into one circuit. Right now that's generating 64 volts, and it's converting it down to 25.7 volts, and it's charging this battery bank here. There's another battery bank which we're going to connect shortly. These batteries come up to an inverter, and this inverter converts the power from 24 volts in the battery bank to normal household current, which would be about 110. And that in turn goes to a sub panel which powers the rest of the house. And this looks more like what you just have in a house. In addition, we've got this pretty cool system. This is a wireless switching system. So we have a bunch of switches. They have no batteries at all, and they control all the lights wirelessly. So for example, from the outside, I could take this. You see this light goes on? That's turning this light off and on with this switch. So I could put this switch in my pocket, or I could glue it to the wall, or I could program several switches to do different things, put one in the bed, or even take one in the car with me. And the one in the car could turn off all the lights when I leave the house, or turn them all on when I get back. So that's pretty cool, from a company called Vertiv. They donated it. And we got a bunch of different experiments to show the difference between compact fluorescent and LED lighting and regular incandescent. And we've got ways of measuring the voltage for demonstration purposes. So the hope is that when this is all done, it's a nice laboratory environment to show students about power consumption, about photovoltaics, about insulation, and all these things, while at the same time providing a proof of concept of how people could live comfortably in a very small space. So we're going to have a kitchenette there. Imagine we have a nice couch, actually we've already purchased, to go right here, and you look out at this nice view of part of our campus. We call this our Superman or South Carolina window, and eventually we'll finish it all out and have it as a demonstration of all kinds of alternative energies.